Hi students, so now I'm going to talk to you a little bit about memory. So all of the information that we're going to store when we create a variable in MATLAB is going to be put into memory. And MATLAB's going to know, based on what information we give it, what type of memory cell to grab and allocate for the particular variable that we are declaring. So you can kind of think of it as memory is like this big stack of stuff, right? So if we want to, say, create a variable like m is equal to 5, and we want to assign it a value, and in our high-level language code, it's going to look like this, right? We have this variable, we call it m, and we're going to store in it the number 5, right? But as we mentioned in the previous video, inside of the computer, we don't have access to this 5 here. Instead, we have to encode this in binary. So what's going to happen is in memory, MATLAB's going to grab a chunk of this. And it knows from this line of code that this particular variable m is going to need to store a numerical value, right? So this is an integer 5. And MATLAB in particular is going to, it makes what's called doubles instead of integers. Some of the other programming languages will have integers and different size integers, but what's bigger than an integer is called a double, and it's kind of short for double precision, and it's going to be much bigger than a regular integer. And the reason why the container needs to be big is because it has to be large enough to store basically any numerical value we might give to it. So MATLAB's going to see this and say, okay, you're making a variable and you want to use it for numbers, so I'm going to grab a chunk of memory that I know is big enough to handle any number you're going to throw at me. Okay, so this particular double for MATLAB is going to be 64 bits, right? So a bit is, if you imagine one of these little cells is a container where we can store a 0 or a 1, right? So if I wanted to encode 5, if we want to know what actually gets stored in memory, we have to look at how the binary number system works. So let me just give you kind of a brief overview of the binary number system. I have another video to include in this class that's actually from the digital design class that will talk about different number systems and how to convert between them. So I'll put that in this class too so you can see. But just to kind of, if you haven't seen this before, decimal and binary. So the decimal number system we're very familiar with, right? This is a base 10 number system. That means that we have 10 unique numerals, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 9 and the 0 and everything in between. So for binary, we only have 2 unique numerals, right? We only have 0 and 1. So I'm just going to put a sub 10 here. I'm going to put a sub 2 here to remind you the decimal is base 10 and binary is base 2. So for the decimal numbers, we would start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the way the algorithm works is we're out of unique numerals, right? So we start over so that you know that the next number from 9 is 10. But algorithmically what we've actually done is in the ones place, since we're all out of unique numerals, we start back over at 0, but then we put a 1 here in the tens place. So we're basically iterating this tens column. So this will be 1, 1, 1, 2, and so forth until we get to 19. And then finally we're out of unique numerals in the ones place again, so we start over at 0 and then we iterate the tens place to a 2. Okay, so following that general scheme that we're very comfortable with since we've been doing it since we were kids, we're going to construct a binary number system the same way, but remember we only have access to 0 and 1. So here's what happens. 0 in decimal is just 0 in binary. 1 in decimal is 1 in binary. But now we can't go on to 2 because 2 doesn't exist in the binary universe. So what did we do before when we were all out of numerals? Well, we started back over at the beginning, right? So I start over at 0 and I iterate in the left position from my 1 spot. Okay, so it looks like 10, but it's actually 2. Okay, great. So then here I can iterate the 1's place to a 1. That one's still a 1. So it looks like 11, but it's actually binary 3. Now at this point, I'm all out of numerals in both places, in both the 1's and the 10's digit. So I do the same thing as before. I start over at 0 and I iterate 1 space over to the left. It looks like 100, but in binary it's actually 4. And we continue on in this way. So that goes up to 1. Now this is all exhausted, so I start this over and I iterate here. And then this goes to 1. And then I start all over and I iterate this spot here. And then this is a 1, 1, 0. I start over here and iterate to the left side. And then, let me make sure these line up. 1, 1, 1, 0, 1, 1. And this is 1, 1, 0, 0, and so forth. So this is how we make the binary number system. In this case here, where we wanted to grab a spot in memory and store in it the number 5, what's actually getting stored is this right here, okay? So suppose we only had access to, suppose we were only given 4 bits in memory. Somewhere in memory we have 4 free bits, right? And this is going to be big enough to store the number 5, right? So we start on the right side, actually. This is the least significant bit, and this is the most significant bit. So this is 1, 0, 1. This actually becomes a 0 because we don't need it. So there's our 1, 0, 1 that corresponds to our 5, right? But the nice thing about MATLAB is that even though we technically only need these 3 digits to store a 5, it's going to give us this giant block of 64 bits so that we could reuse this storage container and we can give it a number like negative 552.6. Okay, so that is more numerical information because of the negative and the floating point decimal, so it's going to require more bits of binary to represent that in the binary number system. Okay, so let me just show you kind of how we might do what it would look like in memory if we were going to do a simple arithmetic problem. So suppose we have our m is equal to 5, and MATLAB's going to grab a storage container for us. This is going to be our m storage container, and it's going to store 1, 0, 1, and the rest of it's going to be zeros, dot, 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 all the way up to 64. And so this is going to be our first cell, our second bit, our third bit, and this goes all the way up to our 64th bit. If you've had experience with other programming languages, lists like this are sometimes indexed at 0 instead of 1. So index means that's the first kind of placeholder. MATLAB starts at 1. So if we have 64 bits, this is actually going to go from 1 to 64 instead of 0 to 63, which is something you might have seen if you've worked with other programming languages. Sometimes that bothers people. Sometimes people really like it, but it is what it is. Anyhow, so if this is our m, suppose we have another line of code that says, all right, I've got an n, and I want to say that n is 3. So MATLAB is going to look at this line of code, and it's going to say, okay, I'm going to grab a spot in memory, and this is going to be my n position in memory, and it's going to be used for numerical values. So I know I'm going to need 64 bits of memory space. Okay, so it's going to grab somewhere in memory. It's going to grab 64 bits from 1 to 64, and this is going to be our n, and in it we're going to store a 3. So remember, stuff gets stored in binary, so 1 1 is binary 3, so bit 1 is going to have a 1 in it, and bit 2 is going to have a 1 in it, and everything else is going to be 0 all the way up to 64. Okay, sorry, let me make that look more like a 0. Okay, great. So then if we wanted to then say, let's create a new variable, and in it let's store the sum of m plus n. Okay, by the way, the semicolon in MATLAB is going to kind of end our statement. It's okay if you don't put a semicolon in, but if you don't put a semicolon in, MATLAB's going to repeat this statement to you. Okay, so I'll show you more of how that works when we actually start running MATLAB, but I'm just giving you some fundamentals now, but I thought I'd mention it. Anyway, so a lot of the programming languages will terminate a line with a semicolon like this, so we just kind of get in the habit of writing it. If we were to do this addition problem in English, like if we were to do this in a math class or something like that, we would just say, okay, I know that this is 5 plus 3, my solution should be 8, right? So this addition in binary is going to be 1 1 plus 1 0 1, right? Because this is the 3 and this is the 5. Okay, so the binary addition looks like 1 plus 1 is 0, we carry the 1, 1 plus 1 is 0, we carry the 1, 1 plus 1 is 0, carry the 1. And you don't have to worry too much about this. I'm not going to ask you to do binary arithmetic, but just so you can see that this is the actual number that's going to get stored in our variable that we're calling x. Okay, so this is decimal 8, this is binary 8, so what gets stored in memory is we're going to have a completely new variable in memory. MATLAB's going to see that this needs to handle numerical values, so it's going to be 64 bits, and in it we're going to store, or MATLAB's going to store for us rather, this. It looks like 1,000, but it's actually binary 8, and the rest of it's going to be zeros all the way up to 64. Okay, and this would be our X cell. So just to kind of get you thinking about these particular like memory cells, so each one of these individually is called a bit. If we have 8 bits, that's called a byte, and we're going to be talking about different sizes of variables. So the two most common variables in MATLAB are doubles and what's called chars. Okay, so a double, this is going to be a numerical value, and this can be anything positive or negative, floating point, or really, really big. Chars, this is short for characters, so this is like, you know, letters like C and D and E and stuff like that. Okay, so if we have basically a list of chars that we stick together, we can make statements and sentences and stuff, and so we refer to those as strings. So string is an array of chars, and we'll talk a little bit more about that later when we actually go to use that, but I just want to introduce you to, these are the two main data types that we're going to be working with in MATLAB. So these doubles, we can actually also store complex numbers in here. So if you recall complex numbers, for a complex number we have the real and then we have the imaginary plane, right? So if we have a number that's only on the real plane, that's going to be a purely real number. We can have an imaginary number here, right? And then this part here is going to be the complex number, and it's the sum of the real and the imaginary parts. So for example, a complex number might be something like 2 plus 3i. Now, as engineers, we can also use, instead of an I, we can use a J. And the reason why is because in the world of engineering, I we usually reserve to mean current, like current in a circuit. And so electrical engineers use J instead of I, where J is equal to the square root of -1, just like the regular mathematical definition of I. Okay, so you can actually take either one of these and you can store them in a variable in MATLAB, right? So you could say that y is equal to 2 plus 3i. And MATLAB will figure out what this is in binary, find a place in memory, and store it in there, okay, as a double. Let's see, so the other one, these characters are, they don't have to be as big as the numerical doubles, right? And we don't need 64 bits to represent one letter. Instead, we just need 16 bits. There's different ways to encode letters into binary, basically. And the standard is Unicode. And Unicode uses what's called ASCII. It stands for the American Standard Code for Information Interchange. And there are some, I'll give you a link. There's a table where you can look up letters and see what their Unicode encoding is. So, for example, in, let's see, I'll say the ASCII binary of the character M, right, that's the first letter of my name, is the number 01001101. Okay, so this is a byte, right, because this is 8 bits of information. 1, 2, 3, 4, 5, 6, 7, 8, right? So this corresponds to a binary number, but in Unicode, the format for this would be U plus, and then here is going to be actually a hexadecimal number, which is a different number system. And again, like I said, I'll give you guys the video that talks about the different number systems. It talks about binary, hexadecimal, octal, and decimal, and relates them to each other. But you can do the conversion between hex and binary. You can do the conversion between hex and decimal to see what this numerical value actually is. So one of the things we'll be able to do is we can encode words and sentences in binary by using this lookup table. So I'll have that us do that activity next. We'll do that on the discussion board, and I'll post that for you as well as the number system video. So let me know if you have any questions about this stuff, and I will be seeing you soon.